Hello, this is the Data Science Learning Community, and we are going to explain the life cycle chart of a package. If you are watching from YouTube, you can join us in our Slack channel. We are always opening new book clubs and be part of the community. So the objective of this chapter are uh, what are the tools that we have to communicate the change when we are changing the package? What tools do we have to study the prior versions? What rules we could follow to decide our package version number? The balance between backward compatible and breaking changes. The difference between a patch release versus a minor release. The cycle stages and the deprecation process. Every package maintainer have these stakeholders. So are the maintainers, also you, also the existing users, and also the future users. And we need to balance how we make the changes to make most of the people happy, because you want to create an open source project, become a critical digital infrastructure, and nobody's going to help you if you are not aware of what the maintainers need to help you. Nobody's going to use it if you're not aware of the user, and your package won't grow if you don't think about the future users. So the first step is we need to communicate the change. We need to define a way to, based on the version number, to let people know if we're in a patch release, just maybe to fix some bugs, or maybe it's a major release when we are adding new feature. Also, we need to explain for every function, argument, and even the whole package, if what is the current stage. If it's an experimental, it's a maybe new idea that you have and you are not sure if that's the best, API possible to share that, or it's a stable function or argument, or it's superseded. So you are not giving much maintenance, you are not adding new things to that function, or it's deprecated. So you are just waiting to remove it for the package. And now the deprecation process in a phase way, a faster way. When do the package change? Uh, how we track that? How do we define that? Every time we place a commit on Git or GitHub, that's only useful for maintainers. For users, the information that is more important is the increase on a package version number and the release to CRAN maybe, or maybe a GitHub release even can help. But you need to release it to some place. To study prior versions, we have the unofficial GitHub from CRAN. And for example, you have this link for use this, where you can check every commit in this copy repo. It is a package version. So if you clone this repo, you will have all the tools that Git have to check the difference between one version and other version. That is going to be really useful. You are tracking the changes. We also have the CRAN archive, where we have the boundlets files. So tar.js, gz, and we can see, yeah, the same versions, yeah, from 2017 to 2023, and even though it's an archive, we don't have the current version that is the 2.2.3. That's the one that they have right now. And of course, the same information that you have in the current repo, you also have available in the original package version, but you will need to make to have more work to do it, maybe by tracking the tags, but that's the way that you can check and track your historical changes for your package. The minimum requirements for CRUN uh, for a version number is it has to have at least 2 integers, so you cannot just release, this is version 1, and then one is version 2. No, that doesn't work that way. Maybe you could write, this is version 1.0, maybe, or 2.0. And then you can use either point or you can use a minus sign. Both are valid. To manage and translate that version number, base I have the package version function. It have these classes, the package version and numeric version are part of the classes. And what is the advantage of making that? For example, you have here, you are comparing versions. You say, 2 should be lower, that this should be forced, but as 2 is higher than 1, that's the only comparison that as a strings, R is making, so it's true. But if you just grab the same package number into the package version function, I will be able to convert not just the one that you grabbed, you will be able to convert both numbers. So now you are getting the same result. Of course, you can grab both around the function, but it's not mandatory to do it. Yep. I will understand. Also, if you want to know what is the current version on installing package, you can use the use utils package version function. For example, if we run package version, use this, we see, I was using the current version of use this when I was rendering this book. And now we can say, of course, the 2.2.3 is lower than the 10 version. So all is okay. Tidyverse also have some rules that we can also copy to track our package version, but it's not something mandatory. Not all package follow that rule, but to me, it seems to be a really easy way to do it. So they always use points. They don't use the minus sign. When you are track and release version, you use major, then the minor, and last is the patch. And you always replace the all 3 elements always. So you won't mislead your users if they are using a patch version or not. So it all good. Most of your releases you have the patch version as 0. So you are not expecting to share errors, in your releases. If you are able to test all your package before releasing, maybe you won't need that too much. But to track the dev version, then you add another point. So you have 4 digits. And they are 9,000. If, for example, you want to track important changes in the develop release, you can add 1, 2, 3 after the 9,000. So you will be able to know when the change happen, but you won't release those changes. It's not stable. Just for you as a developer to track how it's changing your development version. So when we apply a change, we have the backward compatible. It can be backward compatible. So what's maybe a simple definition? The code that was working, still works, but could produce different results in some edge cases. That's basically the results. There are some examples that might introduce some changes, but uh, are not part of the major, or it's not they are not breaking changes. For example, you increase the set of valid inputs. For example, you have a function that used to use data frames, but now also accept matrix. Yeah, that's a good feature. And nobody said that it's a breaking change because you are going to still passing data frames and it's going to keep working. If you fix a bug, uh, of course, maybe some users have write code that depends on that bug, but that's another thing. Also, you add a new function. Uh, it could introduce a conflict. For example, if one of the users is using another package that also have a function with the same name, that could add some conflict. And they were expecting to call a function from their custom for the source package, and then you pass yours. That could be a problem. Maybe adding an argument. It can affect the position-based argument matching for some users. Changing the test or a print method of error could affect the code relies on error message from your package. Yeah, I mean, for someone is creating their package and they expect, use the test that framework and they expect see some error and you change that message. It's not a major release, but that also can affect some developers. Uh, Run the test of your reverse dependencies. That's really interesting to me. When you are going to release your package and you already have a mature package that many people are using in their package, uh, you can also take advantage of the code that they have public available and check if their tests are also passing. And that's also as important, and they do it as frequently that they also guide the development based on those checks. It's like based on the way when you see how people is expecting your function to work, maybe you are going to redefine the way that you are creating that function, or you uh, expand the scope of that function. Oh, I was thinking that people was using this function for this way, but really they are using in another way for another applications. Backward compatible angles. Degree of challenge in behavior, like making something that used to be possible into error, that's a breaking change. How the changes fit into the design of the package, like changing, I know the angles is, for example, the level of change. It's like people say that it's a breaking change when change the behavior, when it change the design of the package, uh, or how much existing use is affected. It's like how much your background code have been changed with your change. Some people say, oh, if the API produce the same outputs always, that's back, backward compatibility. If you haven't changed any part of the design, that also keeps. But yeah, there are different ways to do it. Maybe the ones that I most like is the user interface one. The breaking change type. A change is breaking if causes a CRUN package that was previously passing the check to now fail, and the package original uses and the behavior is correct. So they know that more things can be defined as a breaking changes, but as they have in their package many package that depends on their package, this definition works for most of the cases. So Removing a function is a breaking change. Removing some arguments also is a breaking change. And also narrowing the set of valid input to a function also can be a breaking change. If you, for example, were allowing that people pass a list and now you are asking them just to pass a data frame, that's a breaking change. So let's now talk about the difference between a minor and a major release, or even a patch release. So we are talking about three different things. For example, your current package in the development version is in 0.8.1.9000, and you want to publish a patch release because you find you fix some bugs, you haven't added any significant new feature, there is no breaking changes, you can pass to the next number, 0.8.2. A minor release also includes both features, but also add new features. Uh, and also backward compatible changes. So if you are not making any breaking change, you don't need to create a major release. So this is 0.9. And the major release, you are adding breaking changes. From marketing perspective, also for example, a new feature is really important and you pay a lot of attention to make it. It would be better not to release it as a minor release and just wait it for releasing in a major, because when you change the number, many people will attend to dive into the changes and maybe create some bot plus to share that knowledge. And many people will start using that feature thanks to that in the marketing perspective. But in the other hand, if you release the version 1.0.0, then that indicates that the package is feature complete and the API is stable. Uh, Basically, yeah, you say, okay, we have most of the functions and the package do what I was expecting to do well with at first hand. And I think most of the cases were uh, like maybe by the time you will know it. Like I know that I have 2 years maintaining the package and it hasn't been any request, for new feature and any issue with the current API. Okay, maybe it's time to say that it's stable. Either a minor and major release should share the good news in a blog post as the RStudio team positive does. Uh, for package version, you don't need to do it manually. That was really new to me. I didn't know that we have tools for updating package versions. Uh, when you create the package using use this is the package number, the version that it start with. So it's a good one because you haven't tested. Maybe not many people have used your package. It's the best starting point. But also use versions. If you call use version without any argument, it will also say your description, your news, and also we ask you if you want to, what do you want to do? What the next change in your version? If you want a major, you want a minor or a patch or even other. So you just need to point that and it will follow the rules that we mentioned before. Cons of breaking change. A packet maintainer need to exercise considerable caution and care before introducing a breaking change, as most of our users don't manage packet version in a very intentional way. Uh, for Python, for example, I know that if you change your version, maybe your code won't run anymore because they really introduce many breaking changes very fast. But for R, that's not the way that our users expect that it works. And based in as the CRUM updates really frequently, and sometimes you update one package, and that package depend on other that you use in another project. Uh, Sometimes you update your package and you even don't know that you did it. um, of course, if people noticing that you are making a lot of breaking changes, they will become frustrated and they will stop using your package. Like, hey, life was easier before, and starting using your functions. Of course, you can uh, skip all of these problems by use RBM to try your version for every particular project, but that's not still the the common practice across all our users. What happens if we don't do any breaking change? That can discourage adoption by your new users because say, hey, this repo just maintaining the package, they are not adding new features. So it may be imagine it's a 5 years old library just patching releases. Maybe you don't want to use a package like that. Also, you keep the compatibility is going to also be harder to develop new features or even fix old mistakes. And in your code is more complex, it's gonna be harder to find new contributors. So yeah, we need to find a balance. You are not expecting to add breaking changes every day, every month, but yeah, you need to do it in order to progress in your development. Let's talk about the package evolution approach. So we have different life cycle stages at different levels. So we have the entire package. We can set up a state for a function or even for an argument in your functions. Um, Also, uh, you need to use, we're going to also to discuss how you can transition uh, from one stage to another. Here are basically all the stages that we use in the for the lifecycle package. So we have the stable. Uh, so in the stable, breaking change should be rare and should happen gradually. So you need to make it place a warning. And they don't need any baggage because it's the expected and it's the default for most of the function in your package. The experimental, the maintainer reserve the right to change without just a deprecation process. So that's maybe the state that you want to start your package. So you will be able to change every part of your package as you need it. Deprecated, uh, initially triggers a deprecation warning with information about preferred alternatives until it's removed. Basically, hey, this but we are not going to use support. We are not keep even this function and we are not going to support this function anymore. So hey, start using this code instead. This is the new alternative to make that. And supersede is for legacy functionality is prevented as it is in any type in the time capsules. Like, okay, there are some functions that were so popular that we are not as many people to change their code just because we find maybe a newer way to make the same thing. You can start your state using the utilize cycle. It will apply all these changes. So it will change your description. It will add to imports because it's a dependency that you will need to add to your package. And also you will be able to ask to run these functions across your Rottingham notes for documentation. So to set the package, you can do it even at description level for the function. You can do it in a param just to refer to argument. So you say, hey, this param is deprecated. And also you can use the lifecycle baggage to set the lifecycle for the whole package, as you can see for this new package that translate flash table to Excel. Let's talk about how you can deprecate the function. Lifecycle have the deprecate warn that would place a warning every 8 hours, every time that the user called that function. If you change the argument always to true, the warning will appear every time. So when you know that you are close to remove that, to deprecate that function, that you should set always to true. Sometimes people call a function indirectly. It's like you are using a package and that package use it as a dependency deploy, but it's using a or deploy function. If you don't want to bother the final user just to maintain of that package, you can use a lifecycle deploy solve. So you won't bother the end user with that, just the maintainer of that package. To me, I wouldn't use this. I would prefer to bother the end user, so they will ask to the maintainer the issue. Hey, I'm showing this warning. You should change this, or maybe somebody say, the change is easier to do. Let me just place a pull request. And that's the way that you have your own function. You place this function, and you say, oh, since this version, uh, this old function will substitute with this new function, and that's it. That will show the warning. They also explain the book, even though they don't explain the detail how to use it, that if you don't want to depend on this lifecycle package, you can use the point deprecated or the functions to have a similar behavior. If you are going to deprecate an argument, you follow a similar path. Just you use the deprecated function as an argument to make explicit that you are not supporting that argument anymore, and you use the is present. I think it's for Arlan this function, and say, oh, is present this or is missing. If people is adding that, then you will place the warning, and you basically making the code that you need to make the function run. In this case, they are just changing the argument from path to file, so they just need to date the file variable. And here's how the sample looks like. We also can have deprecated helpers. If you need to deprecate maybe some argument across many functions, you can create a helper. Suppose it's passing the verbose. And here you can see how they do it. They basically say, oh, the default is true. If it's true, if people is passing through to that argument, there's no problem. That's the default behavior. The problem is when they pass false. If they don't pass false, then we need to apply this warning and send them to the user environment that they use this function to. It's like the parent frame function for alarm to affect the global environment and make the warning explicit. That's really useful because you won't need to repeat yourself many times thanks to these helpers. Uh, Dealing with the change in a dependency. Yeah, sometimes the package that your package depends may changes. If the import dependency package have already been released, so you are using the new version of the package, bump the minimum version. You declare if in the description, so it's like, hey, this code used to work from version 0.2, but now we are in version 0.3. So I go to import, and in the parentheses, I would place that the minimum version for this new release of the package is the release package. Uh, and that's a new way. That's maybe the simplest way to do it. You can also work to make your package compatible with both versions. So it's like if you check, for example, that the package version of this your dependent package is minor to the major change, when it was the breaking change apply, then you can apply some logic to make a support to apply the code or just uh, jump to the next part. That that's just basically apply an if to the version and support both. Yeah, it's more work, but it's maybe easier for your users, your final user, that they won't need to update their versions. If the change is not so hard to make. Dealing with change in dependency, if you are responding to not your release, so it's like you are uh, not just supporting after the change was made in the package, but you are maybe checking the development version. Uh, yeah, you would do the same. Like, hey, if you are using a higher version than this one, yeah, you can use the new function. If you are using the other versions, yeah, use the old function and that's it. Superseded functions. Cons, the function is no longer the preferred solution for a problem. That are the conditions. If have enough users and history that you don't want to initiate the process of removing them, that's the two conditions. Yeah, it should be you have a better solution, but the old solution was good enough to many people. So we have the spread that was superseded by the people wider and the gather superseded by the people longer. And they don't receive any innovations. That also is a good practice. And also, you can also support legacy behaviors. Uh, for example, in Tidy 1.0.0, the interface for tidiness and tidiness change, but the old interface remains available via the legacy functions. Also, the group by functions for deploy 1.1.0, they changed the algorithm to make it faster, but that changed the arrangement of the data. So you don't want to affect the arrangement, and that's important to you. You can use the option, the global option, deploy legacy locale to keep the old behavior. So that's all the real example that they do of this behavior. And that's it. I know you want to go back to any part. Have any questions?
I think this chapter was really helpful both to understand how existing packages have been doing things, and then also thinking about going forward with my own packages. I definitely find it irritating how frequently things get deprecated in, say, the tidyverse just when I've learned to use them. But I do appreciate that they follow this procedure to really warn you and lead you into it. So I appreciated this chapter.
Yeah. My favorite parts were of course, the stages are really, it's everyday use. And the versions, I didn't know that base R even have uh, functions to support version and track and also compare version numbers. And also use this version is amazing. So you don't need to bother that. It is an space on what's the next convention, then just summary the convention right here. Also, yeah, the reverse dependency. I don't know how they do it, you know. They need some computational power to make all this because there are many changes. But I think no, that's really useful that they do that. I was thinking like how they manage all that complexity. I know that they have hundreds and hundreds of dependency because they are maybe the most popular libraries in their ecosystem. They have the more popular function in their ecosystem. Well, that's it. I think we are done from this week. This is my last presentation of this cohort. It have been an amazing experience. And see you next week. Let me end this.
Awesome. Thank you for presenting.
I have a comment from John. They
Okay.
almost always get superseded, not deprecated, which means we never change. It's kind of the opposite of how people think about it. Yeah, yeah. The deprecate superseded functions are really good ones.
Yeah, it's something that I like to make sure people understand because they don't go away. Like gather is still there. It's but yes, the best practices definitely change. They've gotten better since they hit 1.0 on almost all the packages. Like they took that to really mean something, that 1.0 means now it's the real thing. Which I don't know, I didn't realize that was happening until a bunch of stuff hit 1.0. And it's like, oh, they didn't think of it as done yet. That's why things kept changing.
Yeah, that's a really good approach. So they rather than breaking a function, they just create new functions and that's it. No,
Yeah.
you want a new behavior? This is a new function. Keep
Yeah.
the old one as is.
One of my favorite things, I think they're still doing this, that when they change something that breaks a package, they will submit PRs to that package to fix it. So they don't have to wait for the developers to figure out how to deal with it. And so actually, like, if you are going to use a tidyverse package in your work, getting your package onto CRAN means they'll fix anything that they break. So it's a useful way to use CRAN, basically.
That's awesome.
Yeah, we really feel, the experience that they have been doing this for a while,
Yeah, yeah. And they finally decided that it was easier to just fix things than to, have to deal with a million people asking questions about how to implement the change or that kind of thing.
No, it's a clever way based on the users that we have. That they are not
Yeah.
tracking you. If you change that, they will break your the code and they may leave R, and that's it. And they don't want that.
Yeah. All right. I officially signed up for next week, so
Awesome.
we're covered through the end. I'll find a time to take a look at those slides. And then in 2 weeks, Jenny Bryan will be joining us. So make sure to submit questions or just have questions ready. I'll try to get a Slido set up before that.
Right. Thanks, John, for making that
Yeah.
contact.
For
So
sure.
yeah, now I'm going to end. Thanks for joining. Bye bye.
Right.